Okay, here we go. AG, we're at 822, core problems. This is going to be a 2-day lesson. So we're going to break out the graphing calculators. So if you don't have your graphing calculator, put this on pause, go get it. Make sure you've got your batteries in it. And you are also going to want to look at the resource page for using the graphing calculator, because it's been a while since you've done the scatter plots and the least square regression lines or determining residuals, and we're going to build on that. So grab your graphing calculator and get your note sheet. If you don't have it, it's posted online, Google Classroom. Go take a look. I think you're going to like this, but we're going to be a little patient. So the first thing that we're going to do is we're going to look at a model that when we do the residual plot and we look at our R factor, we're going to see there's some discrepancies, and we're going to determine that the linear model is not going to be our best choice. Sometimes that's a little tricky to tell. So we're going to look at this dry ice situation. So we're going to start at noon, and we're going to have 15.3 ounces of dry ice. So our X values is the number of hours after noon, and the Y value is our ounces. So just take a minute now. I want you to go into your graphing calculator, and you're going to go into your table option, and you're going to enter your data in, your X and Y values. All right. So when you do that, that's when you want to also make sure that you turn your stat plot on. So that's when you do the second y equals, and just make sure it's on, because we'll eventually want to graph this. Okay, you're entering your data in list 1 and list 2 for the graphing calculator, and then you're going to be good to go. So once you've done that, you're going to create the scatter plot, and we're going to look at the least square regression line. All right. I'm sure you're pausing this. You're going to put all your stuff in, and we're going to look at the least square regression line. So here we go. We've created the scatter plot, and you're looking at the least square regression line. That's where you did the stat, and then you went to calc, and then you chose number 8, and then you just make sure that X is list 1 and Y is list 2. You need to make sure you store your regression line, right? So you're going to press vars, you're going to scroll to the right, you're going to do Y vars, then choose 1 for function, and you're going to do Y1, and then you press your calculate. Hopefully this is all starting to sound a little familiar. So when you do that, you're going to get Y equals negative 0.52x plus 15.21. I'm looking at this equation. It looks pretty good. I am looking at a decrease, right? I'm going to have less of the dry ice over time. If I look at how much I started with exactly on my graph, it was 15.3 ounces. On my model, I have 15.21. Feeling pretty good. Let's take a look at your R value. Your R value should be negative because your slope is negative. Nice job. You got a negative, and we go 4 digits, 0.9979. This is looking pretty good, right? When we square that, we always get a positive number. Just square what's on your calculator. You don't have to re-enter it. And I get 0.9958. Pretty good. Now, look at the residual plot. Now, your residual plot, I just punch it into the graphing calculator. There's a little spot here to put it to plot your data points. Okay, watch the magic. Bam, we got it. Look, wasn't I so quick? That was super quick. So here I've plotted all my points. And what do you notice? We've got this curve. I was feeling pretty confident with this, but yet it's a curve. If it's a curve, a U-shaped, I'm thinking it's an exponential function, right? When I look at the graph, look at that. This looks pretty linear to me. But in reality, there is a slight curve. So what we're going to do is we're going to change our model from a linear regression to an exponential regression equation. So what I want you to do now is I want you to go back into the graphing calculator. And instead of choosing number 8 when you do the least square regression line, so you go to stat, you scroll to along the top to calculate. Instead of choosing 8, I want you to choose 0, right? It might be 10. You might have to go a little further down. And that's going to be an exponential regression, okay? So based on the scatter plot, we're going to come up with an exponential is going to be our better fit, okay? So you're going to make the residual plot based on your exponential graph, all right? So make sure that when you go back in, looking for my highlighter here. I think I lost my highlighter. All right, look at this, flexible teaching here. I'm just going to grab a different marker here, and we're going to make the residual plot of the exponential regression. When you're going to do this, you're going to clear list 3. This is a huge one because it's got the old data, and then we're going to do the residual. So make sure you go back and you clear list 3 before you try to do the residual. So that's the second mode. You get back to the first screen if needed, right? So you're going to do second 0. You're going to, or you can use the catalog, but you're going to go down to the sum, right? And then you're going to press enter. All right. So, once you've done that, hopefully on your graphing calculator, when you look at your residual plot, it will look very similar to mine, right? Now, you get your equation, you're going to get your R and your R squared value. The fact that this residual plot appears to be more random is what's telling us that this is really an exponential equation. So you did your regression, exponential regression equation. You needed that first. That's the first piece. So it goes back to the same thing we did with the regular scatter plots. Once I've got the equation, I can figure out R and we can figure out the residual, and then you can do the square of the residuals. But you've got to make sure that you've stored your equation before you can do your residuals, because it doesn't have anything to compare it to. All right. It doesn't take me long to explain this, but it's going to take you a little bit to punch the data in and produce the graphs. I'm not so worried about you getting all the graphs plotted on your sheet, because you can look at a completed version online, but I do want to make sure that you can do it on your graphing calculator. If we do some kind of assessment, we may have you do a screenshot of it and then share it with us. All right, so let's see what else we've got here. All right, so on the flip side, we're looking at a situation where we have the amount of oil produced from 1905 to 1972. Now, this is a classic. We're starting with, if this is 1905, looking at this scale, 0, 0 is at 0 is 1900. This first point here is 1905. I'm going all the way up. This is 1970, 1972. So you're happy that we actually plotted all of this for you and you didn't have to try to estimate it. So when I look at this graph, does a linear model look like the way I want to go? No way. You can definitely see there's a curve. This is much easier to see than the dry ice. So if it's a curved, then we know that we want an exponential equation. So once again, you've got to enter your data in. Remember, you're really just entering in the last 2 digits. This is going to be 5, 10, 15, 20, 25, 30, 35, 40, right? And then you're going to enter in how many millions of barrels that they produced. When you do it, you do want to double check with your checksum to make sure that you haven't missed anything, because this is a lot of data, and if you're off, then your equation and your R and everything else is going to be a little bit off. So when you're doing your checksum, after you've entered all your data, you press your stat, and you scroll to your calc, and you're going to do number 2 for 2 vars, and then you're going to go to calc and press enter and look for the summation, right? The summation, right? That is this symbol. That's your summation, and make sure that we're in good shape. I know it can be a little frustrating when you are off by 2 digits. So once you've done that, then you can take a look at your equation. So you've got your data in, you've done a scatter plot, right? If you don't graph it, then you have no equation to make a least square exponential equation from. So instead of a regression line, it's going to be, how do we say that? It's going to be a, well, exponential regression is what it is, and it's a curve. So I hope when you do this, you should get y equals 175.17, and then I'm going to go 4 digits, 1.066 to the x. If I do that, I will have a residual of about 0.9976. It's positive because it's a growth, right? My multiplier was greater than 1. And I'm going to get an R-squared value of 0.9952. Looks pretty good. We do want to do the residual plot to see how it looks, and I'm hoping that it looks pretty random. All right? So when you're doing your residual plot, right, you need to do the determine the residuals first. So make sure you hit your stat, edit. You want to go to L3 for list 3. Oh, love it. Here we go.
Can we have a custodian to Mr. Benagi's office on the first floor, please? Thank you.
Okay, see, we're still here and working so hard to make sure you've got a good program. Even Mr. Benagi is working hard. All right, so you've got to make sure you've got your regression, your residuals before you can plot them. So you need to be in L3, and then you need to make sure that's solid and entered, and then you can do your second stat, choose 7 for residuals, and you can fill in list 3. Right? When you did the least square regression curve, you remember you went to, I think it's 0. It's usually on the very bottom, not at the top, to make sure you've got that. Then you can make your plot. Now, you know I've got a y value, so this is my plot. I went 10, 20, 30, 40, 50, 60, 70, 80. So I kept the same scale that they used. Remember, this is just how far my actual data is from my prediction. All right? And we're going to talk about, we can see that this is pretty good when we start with, and then these ones all seem low, and this I'm not that thrilled about. But it's better than linear. It's clearly exponential. So we're going to talk about when it looks like it's starting off pretty good and then it kind of falls apart. And that's going to be our day 2. So at this point, I'm going to ask you to pause the video, and then I think you can come back just for day 2 and we can talk about that. Whew, time flies. Already on day 2 here. So once again, we're going to look at our data. We're going to stick to a similar strategy. We're looking at the same oil productions, right, that we looked at from yesterday. So this is why I didn't really stop everything. I did give you the table again, right? We looked at the model, right? This is our equation. So if y equals 1.75.17 times 1.066 to the x power, if year 0 is 1990 and I want 1996, my exponent is going to be 96. Okay? So this is a pretty epic number. So we're going to get about 80,938. And remember, these are millions of barrels of oil. So that's quite often. So now we're going to look at the continuation of the data for the amount of oil compared to the prediction for 1996 to the amount given on the table. So 1996 on the table, it's way different. It's 23,360, right? Why are we so far off? So what we did over here, look at this. This is 1970, and this table starts at 1974. So once again, I've just plotted these points for you. Can I see that up here, this is kind of a hot mess, right? This is so nice curve, and then it just sort of all falls apart. So once we hit 1982, that's when our model starts to fall apart. What we're going to do is we're going to look at our model and say, you know what, we're only going to use this model for a certain domain. So often, models cannot be extrapolated far from the given data. So if I've got data for so many years, I can predict out a few more beyond that, but I cannot go decades and decades. So models often cannot be extrapolated far from the given data. Right? I can't make predictions that far off. Which makes sense because there's going to be other variables, right? We talked about all those other lurking variables, and those are going to come into place. So above, add the above data. So I've added it in there. I recommend that you just take it off of Google Classroom. It's a little tedious to plot those. We created the updated scatter plot on your paper. So now you've got your graphing calculator, and I want you to enter that data, that extra data, into your list 1 and list 2 from yesterday to see what happens. When we look at this, do we think it's going to help our model or not help our model? Because this is all over the map, it's going to be pretty clear it is not going to work with our model. It's too different. So you can enter the data in and see it for yourself mathematically. All right. So if we just looked from 82 to 96, all right, we're not going to go any further. So 82, let's see, is right here. And we're going to go from there to 96. So we're going to get our own data. So what we're going to do is we're going to create our scatter plot. We're going to look at just this data. If you've already got it in your graphing calculator, right, we only entered the last 2 digits, you could actually delete the stuff out from before. That would be genius, save you a little bit of time. If you've already cleared it all, no worries. You can. It's not overwhelming. So when you create your scatter plot, look at it. How does it look? Take a minute. You entered your data in. Let's see if I can. I want to share mine, but I don't want to share all my answers here. So I'm going to try to cover this up. So I've got my handy dandy completed version. And you'll be able to see. When you do your scatter plot on your calculator, look at that. That one looks pretty what? Does it look curved or linear? Linear. Good job. I knew you were there with me. So this looks like it's going to be a linear equation. So here we go. Ta-da! We're going to look at a linear model for this. If we're looking from 82 to 96, if you round to the nearest whole number, you get y equals 293x minus 4,695. If you went to the thousandths, you'd get y equals 292.679x minus 4,695.143. Look at your residual plot. You've got this. You need, in order to do a residual plot, you've got your least square regression line because you can't compare it, the actual to the prediction. So compare it to your, look at your residual plot. There's no apparent pattern for the residual plot. It looks linear, therefore the linear model is going to be a good fit. Okay, so this is the new piece. We're going to look at regression models and linear models. Sometimes, just like the dry ice, it seemed like, ooh, it could be a good linear, and then when we do our residual plot, we realize it's not a good fit. Or it could be something like the oil, which looks pretty clear. It's got to be a exponential regression, and then we can start talking about domain. And when does it fall apart? All right. So we've got our models, right? So I'm going to use to the nearest whole number. So I'm going to use my linear model of y equals 293x minus 4695. So what we're going to do is we are going to predict how much oil for 1996, and then we can go back. We knew the exponential model gave us over 80,000, and that was way off. So when I plug in 896 for x. Let's see what we get for our y value. Ah, this looks pretty good. Now I've got 23,433 millions of barrels. That's much better. That's a much closer prediction compared to the actual. So the actual was 23,360. The predicted was 23,433. So that is far more reasonable, right? So when we're looking at our domain for our exponential regression versus our linear regression, if I look from 1905, right, when we started, if we're looking at our exponential, where would you say we want to stop? When does it stop becoming meaningful for our prediction? Probably, yep, I agree. Yep, 1980, that sounds good. Nice job, Ryle. So, our X is the year. So, and I'm going to include 1905 to 1980. So now, if I'm looking at the linear model, I know it worked out pretty well for 1996, right? I don't know if it's going to work much beyond that. And then, well, we stopped at 1980. If I look at my data, though, they went up by every 2 years, so I'm going to say 1982. So there's my domain ranges. This is where it's meaningful. All right. So this is going to kind of try to pull things together. So when we went back to Mitchell and we looked at the, when we were given 2 points, problem 81, we were given 2 points and we used y equals ab to the x. And we did our substitution, right? Sometimes we could do an elimination and sometimes we needed to do a substitution, but we could find a and b. And we ended up, for those 2 points, we came up with this equation. He's wondering if he could use the regression functions on his graphing calculator to determine the equation of exponential functions. So what does he mean? And will it work? So he's wondering if he could put the 2 points into a list. So put the 2 points and then go to number 0 and select exponential regression. All right, so give it a shot. So take out the graph calculator, go into list 1, list 2, make sure everything is cleared. You don't want any other stuff messing you up, and see if it would in fact work if we just had 2 points. All right, so what do you think? Did it come out okay? Ah! Awesome, look at that, so much easier. It works, way to go. We got the same prediction. So now, he's looking, well, is it going to work for linear equations as well? So give it a shot. If I've got 2 points, right, I could look at my delta y over delta x. The difference between 729 and 144 is 585. The difference between 6 and 2 is 4. That one was pretty good. So I've got, let's see, now I'm gonna, it goes 146 and a fourth, or 0.25, one left over. There we go. So that's our equation. So if I've got y equals mx plus b, let's say I'm going to go with the smaller numbers, 144 equals 146.25 times x, which is 2, plus b. I double it, subtract, I'm going to get a negative, oh, okay, negative 148.5 for b. So does it work? Totally works, right? When you're looking at your yay. All right, so I've got my equation y equals 146.25 x minus, what was it? Oh, minus 148.5. Okay, now down the bottom, we do have the math notes. So this is just the equal value method when I'm doing, if I would like to, this is a little bit easier. If you have y equals a b to the x, right? If you take your y, if you solve for a, you're going to have y over b to the x. That has to equal the other value of y over b to the x. So all they did here is they looked at your two equations here and they said, okay, so 14 equals a b to the second, and then they said, well, 112 equals a b to the fifth. So if this is 14 over b squared for a, this would be 112 over b to the fifth for a. When I set these two values equal, I think this is often easier to solve. It's your choice. You're going to have a few strategies. When I go to solve for these, you can just multiply. I take whichever one has the bigger exponent in the denominator because I like a positive exponent. I multiply both sides. So now I have b to the third, right, times 14 equals 112. I can divide by 14 and then take the cube root, and I'm going to get b to the third. This is equal to 8, so b equals 2. I'll stick it over here. I have every confidence you can plug that in and solve for a, right? 14 divided by 2 squared, 14 divided by 4, I'm going to get 3.5, right? 7 over 2 is 3.5. So this is going to be the hard part that comes up on at the end of the exam, the unit test, is when you're given 2 points and you have to find that exponential equation. If you can remember way back one in M3 or M2 and you were given 2 points and you had to find that linear equation, that used to stress you out and it was a lot of work, and now it's nothing. So you're going to get there. Same thing with a linear equation, exponential equation. You're going to do your substitution, you're going to have some different strategies, and you're going to look for the easiest path. All right, that's all I got for you. It's quite a bit. Make sure you practice with your graphing calculator, and we'll talk to you soon. Bye-bye.